Do you want to learn C++ from scratch? Well, in this 2-hour course, I'll take you step by step from zero to an intermediate level so that you can start coding today. This will be really helpful if you are a beginner and you are just starting out, or even if you have some experience with C++, and I'm sure you'll learn something out of this. Because I'll be breaking down some of the most important topics down to the very basics, and we are going to learn how everything works. And this is the first part of my data structures and algorithms series that I'm going to upload on my second channel. So go ahead and subscribe to that. The link is in the description. We'll cover everything that you need to know to start programming today, right from the basics. I'll try to cover almost all of data structures and algorithms in 30 videos. It's not gonna be easy, but I'll try to keep it to the point and only tell you what to do along with the questions that you need to attempt. You'll find a lot of resources in the description on where you can read more and questions to solve. But before that, I would like to talk about today's sponsor, PW Skills. Are you looking for a job in today's market? Well, you can check out PW Skills Job Assurance Program. You can choose from Full Stack Data Science Pro or Mastering Full Stack Data Analytics in Data Science. In the Full Stack Data Science program, where you'll go over Python, DSA, SQL, explanatory data analysis, machine learning, deep learning, NLP, Power BI, prompt engineering and LLM, data engineering with PySpark, and by the end of it, you'll be able to build weather app using Open Weather Map API, image web scraper, and in the Mastering Full Stack Data Analysis course, you'll get access to Python, SQL, Power BI, Tableau, advanced Excel, machine learning, and by the end of it, you'll be able to build Facebook database analysis, smartwatch pricing model, political data analysis, where you get a job assurance up to 9 months post-course completion. You have access to doubt support, where you get 12 hours daily, one-to-one doubt support. You also get access to PW Lab. So there's no need to actually go out and buy expensive softwares or systems for your own real-life projects throughout the course. They will help you with a lot of activities that will help you become more job ready, like resume building sessions and mock interviews, and you can get access to experts and get mentored by people from Google, Microsoft, PayPal, LinkedIn. So go ahead and upskill your career with 10x growth with PW and use my coupon code AD2000 to get additional 2000 rupees off on the PW app. So go ahead, check out the description or the pinned comment for more details. Cool, let's get started. So this is the only video you need to watch before getting started with C++. So let's talk about why do we need a programming language. So you and I understand English and your own language, but the computer does not understand this language, not even Python. What computer understands is zeros and ones, which is usually known as machine code. That is 0, 1, 1, 0, 0, something like this. So we need a way to give instructions to computers so that we can tell them to do a few tasks, and there needs to be some sort of a translator between us and the computer so that the computer can understand what we are asking it to do. So this translator is a compiler or an interpreter. So a compiler makes it possible to write instructions in high-level languages which are easier to understand for humans, and then that can be converted into something that can be read by a computer and executed. So if I write a very simple program where I calculate the sum of two numbers, so A is equal to 50, B is equal to 200, and C is equal to A plus B. This is easy for me to understand, but for the computer, this does not make any sense. So what does a compiler actually do? So the compiler goes line by line through your code and checks if every line is correct or not. So whenever it finds a line that does not make sense or there's some sort of an error, it throws a compilation error. And if everything is fine, it compiles it into machine code. There are a few steps in the middle, like creating object code and linking, but let's not get too deep into that. We should aim to cover a lot more topics so that once you go deeper, you get a much better understanding. So you guys understand when you get a compile time error, but that's not the only error. There's another error known as runtime error. What a compiler does is it takes your code and compiles it into an executable, which you can then run. So any error that occurs during this phase is compilation error, and anything that occurs after this is runtime error. So we try to aim to reduce both compile time and runtime error. An example of runtime error is you try to access some memory that you don't have in the program. Cool, let's start with some code first. So I'll try to write a really basic hello world program. So I'm using VS Code, and I'll be using something known as G++ to compile this code. You can Google out how to install a C++ compiler in your own system. It shouldn't be that difficult. So let's create a new file. I'll write it as hello world .cpp. So as you can see, .cpp means it's a C++ file. Similar to if I write py, it will be a Python file. If I write JS, it will be a JavaScript file, and HTML for an HTML file. So these are cute symbols that you can install in VS Code. So let's start a C++ file. So this is an empty file, and let's write the bare bones structure of a C++ file. It will be a main function, and this is it. So let's break it down. In a C++ program, there's one function called main, and the compiler looks for this function and then looks at the open braces and starts executing everything line by line until it sees the closing bracket. Anything you write in this function will be executed line by line. Cool. Let's try to compile it. So I'll be using G++ to compile it. So let's try to compile it. So it compiles properly. And if you see here, I get an a.out file. If I open it, I can't open it. So let me just try to open it with the built-in text editor, and you'll see that this file consists of things that I can't read. But if I try to run it, it runs. So this is the executable file that we were talking about. This is the smallest, or what we say, an empty C++ program. Also, as I mentioned before, I cannot write another int main. As soon as I write it and I make another brackets and I try to compile it, the compiler throws an error. Redefinition of main. Previous definition is here. It's telling me that, hey, you have already defined it. So what's the point? So that makes sense, right? If you are a compiler and you have to read the main function, you'll want it to be 1. So printing something is actually a pretty difficult task because you have to interact with the operating system. Then there's a buffer and there's a lot of things. And everybody has to use it a lot. So what C++ has done is that it has made a printing function that you can use, and then you can print anything you want. And same with taking inputs. In order to use that function, you need to include a library. And that library is IOStream. This means input output stream. And one more thing that you need to use is namespace. So we'll be using the std namespace. So what namespaces do is, so let's say you are writing a program for a car and you define a function known as start, which makes sense. A car needs to start. Let's say I am writing a library for party, and a party has to start as well, right? So I have a function or something known as start in my own library. So your library has start as well. My library has start as well. If someone is using both the car and the party, let's say they are using a car to go to a party and they call the start function. So whose function should I call? The cars or the parties? That sounds difficult, right? So what we can do is we can write all of these functions in the car namespace, and we can write all these functions in the party namespace. So in order to call these, we can just use car : party. This usually means that we are accessing the namespace. So if we don't use namespace std, we'll have to write the functions as std : and then the name of the function. But now we have told the compiler that, hey, we'll be using the std namespace. We don't have to write that. So we can use the function cout and use these two angular brackets and then write a string, hello world. Let's compile the file and let's run it. So I'm getting hello world and I'm getting some garbage value at the end. So this doesn't matter, but I'm getting my hello world. So I was able to print hello world. Let's clean it up a bit. But before that, let's talk about what all the different things mean here. So cout means we are outputting it. But to make it simpler, what I assume is that we are inserting values into cout. And what cout does is it prints it. So cout is a function that prints the values and we are inserting it. So this looks a lot like this. So we are inserting the values into cout and it prints those values. So we can chain it. We can print hello world Ashhad. What should it print? It should print hello world Ashhad, but check this out. It won't give a space because we haven't given a space after this. So we can give a space after this. And it prints hello world and Ashhad and again some empty character. So Let's say I want to print a new line. So I can use a symbol known as \n. So what this symbol does is that it essentially prints an enter character. So the enter on your keyboard, it prints that. So what it does is it prints a new line. Similar to this, we can use /t for a tab, that is tab on your keyboard. So this will give me 2 or 4 spaces. So let's try /n. Let me build it again and let's print it out. So now I am going into a new line because you can see that this random character is gone. So this is used a lot, but there's one more way to write it. We can use endl. To an extent, it means the same thing. It means end line. So let me just clear it, compile it and print it. And see, I get a new line again. So /n and endl are pretty much similar. You don't have to worry about the differences right now. There are a few differences that we can cover sometime later. One thing I want to talk about are these quotation marks. So in C++, these quotation marks means that this is a string. A string is basically a line or a word. So if we don't write this, we will run into problems right now. We'll see when we can ignore them. So 3 takeaways. First, we can chain cout. Second, \n and endl are same with an asterisk. And the third thing is that strings use these quotation marks. Cool. One more thing. You can only print one thing at once. So I cannot print this together. It will give me an error. If I compile it again, it will say that there's some problem here. See, it says. So I need to actually print one thing at once and then use the angular brackets and then print the other thing. And I can print something else and I can print endl and I can keep on going like this forever. So let's actually write a program that does something. So let's write a program that actually does something. So we can have a is equal to 50, b is equal to 100, c is equal to a plus b, and cout c, and a new line. So this is a pretty straightforward program. We are writing values in a and b. We are adding them up and putting them into c, and then we are printing c. Cool. But this won't work because a, b, c are variables. So C++ is a strongly typed language. That just means that we need to define the type of the variable we are making while we are making the variable. So here we have just made the variables, but we haven't defined what type these are. So let's make them int. So this gives our compiler a lot of information that A will store numbers or integers, and it will need 4 bytes of data. Let's talk about what 4 bytes of data actually means. Is 4 into 8 bits, that is 32 bits. 32 bits means that we'll have 4 chunks of 1 byte, something like this. And each of these chunks will have 8 bits for a total of 32 bits. So what is the biggest value that I can store? All of these bits can be 0 up until the last one, or all of these bits can be 1. So the smallest value that we can get is 0 and the biggest value we can get is 2 to the power 32 minus 1. So this makes sense, but we'll come back to this pretty soon. But what you can visualize is something like 5 will be stored like this. So we'll have a bunch of zeros and the last 3 numbers will be 101. 29 zeros before this. So as you can visualize, 5 will be stored something like this. We'll have 29 zeros and then 3 bits where we'll store 5 actually. And how do we know that integer uses 4 bytes? Well, you can Google it, or there's a really good function known as sizeof. So if I print cout sizeof a, let's see what do we get. Let's compile it and let's print it. So we get 4 for this cout. So we get 4 first, which is for the size of a, and then we get c as 150, which makes sense, right? Coming back to this, we actually don't use all the bits. We usually leave the first bit and we either write 0 or 1 here based on the sign, because we'll have negative numbers as well. So 0 means positive numbers and 1 means negative numbers. So that essentially gives us the rest of these bits, which means we'll have 31 bits and it will go from 0 to 2 to the power 31 minus 1, and on the left side it will go from 0 to 2 to the power 31. Why this? We'll talk about that very soon. So int actually gives us a type of data. So we call this as a data type, which makes sense, right? int defines what type of data we are actually storing. So we call it as a data type. And we have a lot more data types. So we have char, which is used to store characters. So it can have anything from small a to z, capital A to z, numbers 0 to number 9, blank spaces, enters, symbols, everything that you can see on your keyboard, and a few more characters. And the total that we have is 127 chars. So if we only have 127, we can store them in 1 byte, right? Yes, we can. And that's exactly what we do. Char CA, if I write char CH is equal to capital A, and then I write cout size of ch, and let's try to compile this. So as you can see, I get 1 for the second cout. So that means char only gets 1 byte. But we just discussed how data is stored in the memory. It is stored in the forms of 0 and 1. And 0 and 1 means that it can only be a number, right? Well, yes. So we actually don't store all these characters directly. We give them a number, and that table is known as an ASCII table. This is how an ASCII table actually looks. So as you can see that this is the number that we have assigned, and this is the character that we have assigned it to. So you can see that exclamation is 33, hash is 35. Similarly, the character 0, not the number 0, but the character 0 is at 48. Capital A is at 65 and small a is at 97. And this goes on until 127. So we have a total of 127 characters. Let's talk about characters for a second. If I have a character A in variable ch and print the variable, I get the character A. You know what? Let's name it as this. One thing to note is that we use single quotations with characters. So what will happen if I write this? Think about it. Let's go through this. So as you can see, so the first A is actually a character A. The second A is the variable A. And the third A is the string A. What should it print? According to me, it should print A, X, and A. Why X? Because this is the variable which we have defined to X. So that will go here. Character and string will be printed directly. So our final output should be AXA. Let's build it and let's print it. So we get AXA. The difference between a character and a string is that you can only store one single character in char, whereas in a string you can store a lot more characters, and it requires a lot more space to build a string rather than a char. And this A is actually a variable. So if I give this capital A and I do int b is equal to A and I print B, let's see what this does. So it prints 65. Let me go back to the ASCII table. You'll see here that it has printed the ASCII value of the character A. So it takes this character and it stores 65 in the memory. And then I make an integer B and copy A's value in this. So it goes to that memory location where we have stored 65. I have 65 here and I can copy that into B. So it copies 65 into B, and then when we print B, so it prints 65. What it did here is it converted a character into an integer. This is known as type conversion. And since we didn't actually do this, we call it implicit. Can we do it ourselves? Yes, we can. Let me show you. Instead of printing B, if I print A and compile this, it should print the character A, right? It does. But if I give in brackets integer and then print A, it prints 65 again. So here what I've done is that I've specifically told the compiler that, hey, I don't care what A is, just give me the integer value of A. This is known as explicit type conversion. And so you know what? We can do it the other way around. So if I say, hey, give me the character value of 65 and I print that and I compile this, it gives me A when I've just given it 65. So you can see how we can convert it. So what will happen if I write int C is equal to 69, char D is equal to C, and I print D and I build it, I get E. And you know what? I can actually print character A plus 10 and I can convert it into a char. and I can give this into brackets as well. And if I print it, I get K. So it goes from A, increases 10 numbers, and it goes to K. So similar to characters, we have float or double. Both of them hold floating point numbers, that is 1.23, anything with a decimal. And the difference between both of them is that float has 4 bytes of memory and double has 8 bytes. So that just means that double can store a lot more numbers with a lot more precision, and precision just means the number of elements after the dot. Similarly for int, we have something known as long, which is just int, but it gets 8 bytes, so it can store larger values. But let me show you something interesting with floats. So float a is equal to 3 by 2. This should give me 1.5, right? Let's print a. Build this file. It doesn't give me 1.5, it gives me 1. So why? Let's talk about what's going on here. So once this right side is solved, C++ copies the answer into A. So what it does is, it creates an integer 3, an integer 2, and then divides them. So this gives me an integer 1, because integers don't have decimals. So it gives me an int 1, and which is then copied over to A, which we don't want. In order to get out of this, we can actually convert one of the numbers into float. So this converts it into float or double. And if I print it again, now I get 1.5. So now what it does is that it implicitly converts 2 into float as well, and then divides this, which gives me 1.5, and then copies that over to float. So you know what, let me just try something else. What if I store it into an integer b? So let's see what we get. So I'll compile this and print it. So what's happening here is, it is still computing 1.5, but when it goes to store that in integer b, it drops everything after the decimal. So 0.5 is dropped and it only stores 1. So this is a place again where type conversion is happening implicitly, and you should know about it. One thing you can do is write ceiling. So what it does, it rounds it up to the next highest number. So this should give us 2 instead of, yeah, it rounds it up. So let's say if it was 2.9. So what happens is, it rounds it up, and if we write floor, so when we use floor, it actually rounds it down. So ceil and floor are 2 of those functions. So till now, did you realize that whenever we were initializing a variable, we were putting a value in it? But we don't have to do it. So what we can do is, we can make an integer c and then initialize it at some other point and then print it. This should be completely valid, right? It is. C is printed as 10. But what will happen if I move this print statement before I initialize the variable? So if I build it now, so I get some value that I don't know where it has come from. I've never set this value in my program, and nowhere in my program have I used a number this big. So where did this number come from? So this number is something we call as a garbage value, because this was already inside whatever memory location my C has been assigned to. So there's a bunch of memory in for our program. So the compiler has just taken some of this memory and given it to us as C. Now we don't know what was in this memory, right? There could be anything here. So we call this a garbage value, and you should take care of it. Never use variables before you actually initialize them. So similar to cout, we can take numbers input from the user. So we can take cin, let's make a variable b, and we can take the input from the user. It's completely opposite to cout. Instead of out, we'll write in, and instead of left angular brackets, we'll write right angular brackets. Think of this like someone writes 2 on their keyboards. So that goes to cin, and cin gives it to the right. So what C++ does is, whether it's 2, 3, 5, 7, 9, however, C++ reads all the numbers and assigns the first number to the first variable, which is b here, and 3 will go to the second variable, 5 will go to the third variable, and so on. So let's circle back to how numbers were stored in the memory. So for positive numbers, we know that they are stored like this. Let's say 5. So it is stored like 0, 0, 0, 0, 0, 1, 0, 1. There's a lot of zeros to the left of it. Let's not go there. But how will you store -5? The first bit should be 1 to denote that this is a negative number, like we discussed. But we don't store the rest of the numbers directly. What we do use is something known as 2's complement. So the main reason is, let's say you have a number 10000 and all zeros. So what is this number? Is this negative 0? But that doesn't make any sense, right? So what we do is we take a 2's complement. So for 5, let's say the number was 000000101. This was 5. So what we do is we first take a complement of every bit. So 0 becomes 1, 1, 1, 1, 1, dot, 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 1, 0, 1, 0, right? And then we add one more 1. So we'll add 1 into this. So this becomes 1, 1, 0, 1, and then all the way up till here we get 1s. This is the 2's complement. So this means negative 5. Again, to get the number back from here, we take a 2's complement again. So this becomes 0, 1, 0, 0, and we add 1 to it. So we get 0, 1, 0, 1, which is 5. And this is exactly how the number is stored in the memory. So negative numbers, we take 2's complement. Positive numbers are stored directly. So it starts with the 0 and then we store the number at the end. So this bit, the first one, we call it as a sign bit because this gives us the sign of the number, if it is positive or negative. So our numbers go from minus 2 to the power 31 to 2 to the power 31 minus 1. Why this extra number? Because we don't have minus 0. So this extra bit is actually used for the last number 2 to the power 31. So the range for int is minus 2 to the power 31 to 2 to the power 31 minus 1. But sometimes we don't need to keep negative numbers. We can actually remove the sign bit and use it as a normal bit. And if we have to define a variable like that, we call it an unsigned int. And we can write x. And this is how you define an unsigned integer. Also, a bonus point, cin actually skips all the white spaces that are spaces, tabs, and enter key. So if you want to actually take in these white spaces as well, you can use something known as cin.get. What it does is that it reads one character from the stream. It could be anything. It could be a space as well. And it gives it to you as a character. So you need to store it in a char, and if I print the char, it will print an empty space. Let's go over all the operators. So you have already seen we have plus, minus, divide, multiply, and a remainder operator. So I'll give you an example. So 5 mod 3 gives us 2. So 5 mod 3 gives us 2 because 2 is the remainder if we divide 5 by 3. So these are known as arithmetic operators. Next, we have relational operators. So relational operators tell us the relation between two numbers. So it can be greater than, less than, greater than, equal to, less than, equal to. How do we define if a equals b? This is not correct because this will copy the value of b into a. We have a relational operator called double equals to. So double equals to is used to compare two different values if they are equal or not. So double equals. And we have one more, that is not equals. Next up, we have logical operators. So logical operators are and, or, not. So these are like gates. So AND gate has a true, true will give us true. And if anything is false, it will give us false. Similarly, OR gate gives us true if anything is true. And lastly, NOT gate gives us the negative of whatever value we pass through it. The output from all the relational and logical operators is a bool. What is a bool? Let's talk about. Bool is a Boolean number, that is 0 or 1, true or false. False being 0 and true being 1, just so you are sure about that. And it uses 1 byte of memory, but it only uses like 1 bit out of that because it stores the value as 0 for false and 1 for true. Also, there are bitwise operators. So we have the bitwise and, bitwise or, bitwise and the not, bitwise XOR, left shift and right shift. So essentially we have these bitwise operators. But what bitwise AND does is, so this is like the AND gate, but we do it bitwise. So let's say we have 2 and 3 and we do bitwise AND. Since this is an AND, both of them need to be 1 for the output to be 1. So we get 0 and 1. Similarly for bitwise OR, any of them can be 1 and we'll get 1. So this will be 1, 1. What NOT does is that inverts all the bits. So 0 becomes 1 and 1 becomes 0. XOR is a little special. So XOR is odd ones counter. So anytime there are odd number of ones, we'll get a 1, else we'll get a 0. So something like 0, 0, 1, 1, 0, 1. So let's say if we have 2 and 3 and we do XOR, which is denoted by this symbol, caret symbol. So what we'll get is, since this is an odd number of ones, we'll get 1. This is an even number of ones, we'll get a 0. And since there are no ones, we'll get 0. So we'll get 1. What left shift does is that it moves all the bits ones to the left and deletes the first bit on the left. So something like 0, 0, 0, 1, 0 actually becomes this bit. So this bit is deleted and this becomes 0, 0, 1, 0, 0. Everything moves to the left. Similarly for right shift, the last bit is deleted. So 0, 0, 0, 1, 0 becomes, this bit is deleted and it becomes 0, 0, 0, 0, 1. And one bit is this bit is added and here this bit is added. What NOT does is that it makes negative numbers positive, but in a weird way. You can actually try to do this. So what you can do is, let's say you have a number like this, that is 0, 0, 0, 0, and then you have 1, 1. This is the number 3. And when you do not 3, you'll get 1, 1, 1, 1, dot, 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 and 0, 0. And if you take the 2's complement for this, you'll get 0, 0, 0, and 1, 1, that is number 3. And so this is a negative number, and plus 1 will give me 0, 0. So this will be negative 4. So not 3 is negative 4. Yeah, it is a little weird. We'll go over this in a lot more detail once we actually start using them. So let's talk about conditionals. Do you remember that while making flowcharts, we had something known as decision boxes, where we could write a condition, and if it was true, we would go in one direction, and if it was false, we would go in another direction. Well, this is what a conditional is. And in C++, we use if and else to define a condition. If the condition is true, we go into the if block, and we'll execute everything in the blue region. And if the decision is false, we'll go into the else block, and we'll execute everything that is in the green region. So what's going on here is, the condition that we pass to if, that condition is checked and a Boolean value is generated that is either true or false. And if a true value is generated, we execute some piece of code. And if a false value is generated, we go to the else block and execute that piece of code. So a greater than 10 will give us a Boolean value. That means it can be true or false. So some values that you don't know but are actually true are any number other than 0, it be positive numbers or negative numbers, non-empty strings, and a memory location. All of these when passed to if will give us a positive answer. But empty strings, the number 0, null, all of this will compute to false. So let's try to actually implement it. So this is how you write an if-else box. So first you have if, and then you pass a condition, and then you write the piece of code that needs to be executed if the condition computes to true. Else we'll go into the else block, and everything written in else will be executed if the condition is false. So let's write a program that takes a number from the user and prints if it is even or odd. So we'll use the mod operator. If we divide the number by 2 and the remainder is 0, that means it is even. So we can print that this is an even number. Else we can print this is an odd number. And if I compile it, let's enter 10. And we get an even number, which is correct. And let's try this for 11. We get an odd number. So one thing to note here is that we always need an if condition, but the number of else conditions, it can vary from 0 up till any number of conditions. And how can we do that? Well, we can chain these else to another if statements. So let's say if I want to rewrite this and handle n is equal to 0 case. So we'll write another if condition where n is 0 and we'll print 0. Cool. Then we'll go in else and we can write all of this into else. Cool, this works. But what C++ allows us to do is that we can actually chain this else and if, and we can write this last else, and we can write another condition here. If you want a third condition, we can write another else if, and we can keep on going for how many conditions we need it. And lastly, we can write a final else, or if we want, we can just simply skip everything and just keep an if condition that, hey, if this condition executes to true, just run this piece of code under it and then move on to the next line. Else just skip this piece of code and directly move on to line number 10. Which makes sense. So let's write a program where we take a number from the user and print if it is a positive number, negative number, or 0. So we'll check if the number is greater than 0, and we can write that this is a positive number. If not, we can check if the number is less than 0, and we can write that this is a negative number. If none of them matches, we can be sure that it is not greater than 0 and not less than 0. So it is definitely 0. I'm assuming it to be 0 because we have handled everything else. So we can write that this is 0. What you can do is, if you just want to be very sure, you can just write it that if n is specifically equal to 0, we'll write 0. And we can skip the else condition because we don't need it now. So these are all the 3 conditions. Let's try to build it. Let's try to enter minus 100. I get a negative number. Let's try to enter positive 100. I get a positive number. And for 0, I get 0. So if has given us something very interesting. Can you see these curly brackets here? What do these mean? So this is a block of code. So everything inside this block will execute when this if will evaluate to true, right? And the same goes for this block and the last block. So I want to talk to you about something very important. So let's say I set up a number A and set it to 10 here. Can I come outside and print that number A? I should be able to, right? I have initialized a variable, I have given it a value, and I'm going to access that value. It should work, right? Let's try. So I cannot compile it. I am getting a compilation error that we have an undeclared identifier A. The compiler doesn't know what A means. Why is that? We have defined it. Well, this is where scope comes in. Let's talk about scope. So scope is actually an area in your program where a specific variable is alive. What do I mean by alive? So let's say in the if condition where A is equal to 0, you want to perform some operations. So these operations can be anything and it might require a variable B. We'll start here and this variable will be deleted once we reach this ending bracket. So that means the scope of variable is from here up until we reach this bracket. This is the only place where we can actually access the value of B. Let me show you something very interesting. So let's say that I have a variable A, which is equal to 10. So what will be the output of this program? Think about it. Let's build it. So let's go through this. So we make a variable A. We check whether A is equal to 10, which it is. So we'll redefine A to 100 and then print A and then print A again. Well, let's try to run it. So for this print statement, I get 100. And for the second print statement, I get 10. So for this bracket, the compiler has assumed the value of A to be 100. And for the complete program, the compiler has assumed the value of A to be 10. So we cannot redefine a variable in the same scope. But since we are in a different scope now, we can redefine A. To make it simpler, just assume that a scope of the variable is the curly bracket surrounding it. So for the outer A, the scope of the variable is from line number 4 to line number 11. So for the inner A, the scope of the variable is from line number 7 to line number 9. And after line number 9, this A gets deleted. So when we try to print A here, it first checks the local scope. It says, okay, I have an A, and it goes ahead and prints that. If we didn't have an A here, it would have gone to the outside scope and checked, okay, we have an A which is equal to 10. So it would have printed 10. If I write int B is equal to 400 and print B here, it does not have B in its local scope. So since it does not have B in anywhere in its local scope, so it goes to a scope above it and checks B. So it gets B is equal to 400. So it prints 400. It picks up A from here and B from here. So once we are outside of this, this A is deleted and we print A, the A defined at line number 5. We check the local scope and then we go outside of it. And I cannot actually redefine A in the same scope here. If I try to redefine A, the compiler will give me an error. It says, hey, you are redefining A, which is not allowed. And there's a previous definition already there, which makes sense. So you need to be very careful with your variables and if they are available in the scope you are using them or not. Cool, let's talk about loops now. So in C++ or any programming language, when you have to run a piece of code multiple times, we use loops like we did in the flowchart. And if you haven't seen the flowchart video, then it will be linked somewhere up here. Go ahead and see it. It will help you to understand everything that we are currently discussing. Let's talk about while loop, which is very simple. While there's a condition which is true, we'll execute the code in blue. And once we have done executing the code, we'll come back here. We'll check if the condition is still true, we'll go ahead and execute the code again and again until the condition becomes false. So let's try to print first 10 numbers using while loops. So we'll set a variable I, we'll set it to 1, and until I is less than or equal to 10, we will print I, and we will do I is equal to I plus 1. Before moving forward, let's talk about this I is equal to I plus 1. What we are doing is we are taking I and increasing its value by 1. But C++ has a shorthand notation to do this. So I plus equal to 1. This is the same as I is equal to I plus 1. I plus equals to 10 will be I is equal to I plus 10. Similarly, we can do I minus equals or I multiplication equals or I division equals. This gives us I is equal to I minus 5, 10, 15. Let's try. I is equal to I minus 5. This will give us I is equal to I into 10, and this will give us I is equal to I into 15. So this is a shorthand notation that we can use. So instead of writing I is equal to I plus 1, I can write I plus equals to 1. And there's another way to write this. So if we are only incrementing it by 1 or decrementing it by 1, we can use something known as unary operators. So that will be I plus plus or plus plus I. So both of them increment the value of I, but there's one difference that you should know about. So let me just comment the code. This is how you comment C++ code. What commenting does is that it tells the compiler to not look at these lines and just go ahead and look at the rest of the program. So these all lines will be skipped by the compiler, and that's why they have been grayed out by VS Code. This is how you define a single line comment, that is by double slash, and this is how you define a multi-line comment by slash and asterisk. I plus plus and plus plus I. What's the difference? So this is post increment and this is pre increment. Basically, what we can do is int a is equal to I plus plus. What post increment does is it breaks it down into two steps. It does a is equal to I, that is copy the value of I into a, and then it does I is equal to I plus 1. This is what this line means. Similarly, if we write int b is equal to plus plus I, this does the same operation, but it increments first and then updates the value. So this makes it I is equal to I plus 1, and it then copies the value to b. So if I print a and b here, so what should we get? So what happens is that I is 1, it copies its value into a. So a becomes 1 and then I becomes 2. Correct? Now for b, it actually increments its value first, so I becomes 3, and then it copies its value to b, so b becomes 3. So while printing a and b, I should get 1 and 3 respectively. We are getting 2 and 4 because we are actually incrementing it before I actually did. If I comment it out and if I build it again, we should get 1 and 3. So we are getting 1 and 3, which is exactly what we should be getting. So what does this line actually mean? Post increment I and then post increment it again. So what it tries to do is, it says, okay, I need to increment I, but you know what, since this is a post increment, let me do everything that needs to be done after, and then I will increment I. So I need to do I plus plus after this. So that doesn't make a lot of sense, right? It's not allowed to write I plus 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 plus, but you can write plus 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 I. This is a completely valid syntax and it compiles. So what it does is that it increases the value of I. So I becomes 2 here. And then it increases it again. I becomes 3, which makes complete sense. Now coming back to the while loop, we instead of writing I plus equals to 1, we can just write I plus plus. Since we are not assigning or doing anything, this and plus plus I will do the same thing. They'll just increment the value of I. So this can be used to print the first 10 numbers, and it is working. So let's write a program to calculate the factorial of a number. So we'll take a number from the user, factorial is equal to 1, we'll set a number to 2. So while that number is less than or equal to n, factorial into equal to I. So we'll multiply I into the factorial and we'll do I plus plus. And once we are out of it, we can print factorial. So if I write 5, I should get 120, which is the correct answer. This will be 5 into 4 into 3 into 2 into 1. So I want you to write two programs. One will calculate the sum of numbers from 1 to n, and the second one will do the same, but it will segregate it into two buckets, one for the even numbers and one for the odd numbers. So basically what I want you to do is, So the first program will do 1 plus 2 plus 3 up till n. And the second program will make two buckets, even sum, which will be equal to 2 plus 4 plus up till we reach n. And the second one will be odd sum, which will be 1 plus 3 up to n. So try writing a program with while loop that does these both calculations and print the result. Cool, let's start with patterns. When I was starting out, one thing that helped me the most was trying to print patterns with loops. It gave me such a good understanding of how loops work, how index works, everything. So try to print a lot of these patterns. I will do a few with you, but I'll tell you where you can pick more. So I want you to print a pattern like this. For n is equal to 4, we'll have 4 rows, the first row containing 1 star, the second row containing 2 stars, and so on. You know what? Let's break down this problem. So let's start with n and take that from the user and run a loop from 1 to n. And we'll write I. So we'll write the row number that we are currently at and then increment I. So for 4, we are getting 1, 2, 3, 4. That's correct. So I'll need to print 1 star, then 2 stars, then 3 stars, and then 4 stars. So I need to run another loop. Currently we are printing 1, 2, 3, 4. So I'll need to run another loop that prints these many stars. That could be 1, 2, 3, or 4. So let's, instead of printing I, let's comment it out and we'll run another loop. So it will go from 1 and it will go till I. And we'll print a star and we'll increment the second loop. Let's see if it is working. Okay, I forgot a semicolon. Let's enter 4. So we are getting our stars and we are getting the number of stars that we actually need. But we are not adding a new line. And where will we add a new line? After every row. So once we have printed the stars for a single row, we'll print a new line. So for 4, we are getting our desired star pattern. Yay! Cool, let's try something different. You know what? Now instead of printing this, I want to print for n is equal to 4. I want to print 1, 1, 2, 1, 2, 3, and then 1, 2, 3, 4. Since these are comments, the compiler is ignoring them. So let's copy this because this will be very similar. So instead of printing stars, I need to print J, because what we were actually doing is we had I 1, 2, 3, 4. Now for this, we are running a loop for J and it is going 1. This is going 1 and 2. This is going 1, 2, 3. And this is going through 1, 2, 3, and 4. So the loop running on J is this, and we can essentially just print it. So let's do that. So we'll print J and we'll print a space after that. Let's see if it works. It will be patterns 2. And it works. Cool. Now instead of this, how about for n is equal to 4, we write a program that writes 1, 2, 3, 4, then 1, 2, 3, then 1, 2, and then 1. A pretty similar pattern, but in the opposite order. So let's see where our I and j is. So let's see what the value of I is. So our I is going over 1, 2, 3, and 4, but now we have to print 1, 2, 3, 4 for this row. We have to print 1, 2, 3 for this row, 1, 2, and 1. What I can see is that we are running the loop 4 times, 3 times, 2 times, and 1 time. So for a given I, we are running the loop n minus I plus 1 times. Because our n is 4, and for I is equal to 1, the loop is actually 4. For 2, the loop is 3. For 3, the loop is 2, and so on. So this will be, so I'll copy paste some of this code up until here. So we are running I from 1 to n. Now we'll start j from 1 And while j is less than n minus I plus 1, we will see out the value of j, give a space, and once we are done with it, we'll increment it, and then we'll give a new line and we'll increment I. Let's try to build this for 4. We have made a mistake. The mistake that we have made is that we are running this loop. This needs to be less than or equal to, because we actually need to go from n is equal to 1 till 4, and we are stopping at 3, which is not what we need to do. So it should be less than equal and for 4, and I get the desired output. So I want you to print the star pattern for this. Instead of writing 1 2 3 4, you need to print star. So you'll need to print the star pattern, and this should be relatively easier because you don't need to print the value of j. So think about it and write a code for this. So the next pattern that I want you to print is try printing this for n equals 4. So think about this. I think this is very similar to the first pattern that we were printing. Let's copy paste this. If you'll think about it, I don't need to print 1 1 2 1 2 3 1 2 3 4. Instead of printing this 1, I need to print 2, and this will be 3. And this is like a counter is going on, and every time we print the counter, we update it. So once it was 1, then it becomes 2, then it becomes 3, then it becomes 4 and 5 and 6, and it goes on. So instead of printing j, let's set a counter, basically which counts, and we'll print the counter, and we'll do counter plus plus. Let's see if it compiles. Let's try to compile this. So now we are printing 1 2 3 4 5 6 7 8 9 10, which is what we were supposed to print. Cool. Something I can do here is, instead of writing it in a different line, I can just write counter plus plus. So what it will do is, it will first print the counter, and it will then increment the value of counter, and this should give us the same output. Exactly. So this is how we can use post increment in real world scenarios. So think about this for a moment. If I give you an n which is equal to 4, I want you to print this. This should be right aligned. How can you do that? Well, if you think about it, essentially what you are doing is you are printing some spaces, and then you are printing star. Then you are printing some spaces, and then you are printing some star. And it goes on. So for I equals to 1, you are printing 3 spaces and 1 star. For I equals to 2, you are printing 2 spaces and 2 stars. For I is equal to 3, you are printing 1 space and 3 stars. And for I is equal to 4, you are printing 0 space and 4 stars. So one correlation I can see is that I and the number of stars is same all throughout. So you are printing I stars. This is the easy part. How many spaces are you printing? So for n is equal to 4, I think you are printing n minus I spaces. 4 minus 1, that is 3. This will be 4 minus 2, that is 2. This will be 4 minus 1. So this will be 4 minus 3, that will be 1, and so on. So we need to print 2 things here. So let me just copy some of this code because I'm way too lazy to write it again. So I'll go from 1 to n. Then we'll need to count the number of spaces. So the number of spaces will be from 1, and while spaces is less than or equal to n minus I that we just saw here, I can print a space. We can do a character. Now I've printed 3 spaces for the first line. Now I have to print stars. So let's do stars is equal to 1. And while the number of stars less than equal to I, I'll print the number of stars. And I will do stars. So I'll print I stars, and first I'll print n minus I spaces and I stars. After I'm done with all of this, I'll enter a new line, and I'll say that I'm done with this row, so increment I. Let's try to build this. So we get our desired output. Great. You need to solve a lot more questions like these because these are not easy questions to solve. And this will help you a lot with understanding how looping works, how variables work. So I'll be going over one last pattern, which is a little difficult, but I want you to actually go to Google, search for pattern printing questions and try to implement at least 20 of them. So the pattern I'm going for is for n is equal to 3. I want to print. So for n is equal to 3, I'm trying to print this. Let's copy some of our code. First, let's think for a moment what we are actually doing here. I think this question can be divided into 3 different parts. One will be the number of spaces. The second will be this part of the array. And the third will be this part. This is how I think this question can be divided. So for I is equal to 1 and n is equal to 3, we'll print 2 spaces, and for I is equal to 2, we'll print 1 space. So one thing is very sure, that we are printing n minus I space. Then we are printing 1 character here, 2 characters here, 3 characters here. So next we'll need to print I numbers. And lastly, we are printing nothing here. We are printing 1 character here and we are printing 2 characters here. We'll need to print numbers starting from I minus 1. I here is 3. So we are printing 2 and 1. Here I is 2 and we are printing 1. So we'll need to print numbers from I minus 1 to 1. So these are the 3 things that we need to print in every row. Cool. Remove all this and let's just keep this part. So for a single row, we'll need to print n minus I spaces. So let's take spaces is equal to 1 while spaces is less than equal to n minus I. We'll print the space and we'll do spaces plus plus and we'll do spaces plus plus. Cool, we are done with the spaces. Now let's print I numbers. So int number is equal to 1 and we'll go up to I and we'll print the number. Let's just name it as numbers instead of and this as space because it will be easier. And once we have printed that number, we'll increment it. Lastly, we have to print the reverse number. That will be I minus 1 and it will go until the reverse number is greater than or equal to 1. So we'll go from I minus 1 to 1 and we'll print the reverse number because we are going from I minus 1 to 1. We are going down. So you'll need to decrement it. Once you have decremented, so this will be minus minus. Now we can do a new line because we are done with a row and we can increment I. Always be very clear that you'll hit this condition. If you don't hit this condition, this while loop will run forever and your program will get stuck. It will go into an infinite loop and then you'll have to kill the program to stop it. So now that we have written this, let's try to print it. So we are getting our desired output. So there are a lot of these questions. One more variant of this is where they'll ask you to print something like this, basically a diamond shape. So what you'll need to do is you'll need to run this loop twice, or you can make adjustment and do it in one loop. It depends on you, but go ahead and try to print these patterns, solve at least 20 of these questions. Cool. Now let's go to our first pattern. One thing that you'll notice in every pattern that we have printed is while running a while loop, we are using some things a lot of times. So we are setting I is equal to 1. We are checking a condition and then we are updating I. We'll go to another one. We are setting I, we are checking it, and then we are updating it. Setting it, checking it, and then updating it. Same with J. Setting it, checking it, and then updating it. So if we have to actually define it, we are doing 3 different things. We are initializing, we are then checking a condition, and lastly, we are updating I. So we have another loop that does all these 3 things in one single line, and we call it a for loop. So instead of writing all these lines differently, we can include all of them in a single line and we call it a for loop. And it helps us because we won't forget things and we won't run into infinite conditions. This is how you write a for loop. We are initializing our I here, and then we are checking the condition here, and then we are updating it. So what happens is, first I will be initialized here, and then we'll go and check the condition if I is less than n, which it is. So we'll go and execute everything inside this for loop. And once we are done executing, we'll go and increment I. Once we increment I, we'll go ahead and check this condition again. If it is still not met, we'll do it again and again. And we'll keep on executing this until this condition holds true. So let's try to print the first n numbers with for loops. So let's try to print the first n number. So we'll take n and then we'll run a for loop from I is equal to 1 and we'll go till n, and every time we can go ahead and print I. And once we are done, we can enter a new line. Cool. Let's build it. So we can print the first 10 numbers. It is pretty much similar to the while loop. It's just that we can write it in a much more concise way. Also, you can define multiple variables here and you can check for multiple conditions. So I is less than n and j is less than or equal to n. And you can increment multiple variables here as well. This is a completely okay syntax. It will initialize 3 variables, it will check this complete condition, and it will increment 2 variables. Let me ask you something. So what if I print I as well? Will I be able to access I? I can't. Why? So I'm not able to actually access this I because the scope of this I is only limited to these brackets. So once we are out of this for loop, I gets deleted. If I want, I can actually skip some parts. So I can take this I outside and this will be a completely valid syntax. So let me just check it once. I forgot the semicolon. So this is a completely valid syntax. And this last I 11 is actually this. So I can actually access I out of this for loop because I've declared it before the for loop. And as you can see, I can actually skip segments of the for loop as well. One thing that I want to talk about here are 2 words, break and continue. So whenever we are in a loop and let's say I want to print the first 10 numbers, but I don't want to print 2. So if I get 2, I want to do something that skips this iteration. We call this iteration, that is 1 iteration, 2 iteration, up to 10 iterations. So whenever I get the number 2, I want to skip this iteration. We can do this with continue keyword. So whenever the compiler gets the identifier continue, it just skips everything and moves on to the next iteration. Similarly, let's say I want to print them like 1, 2, 3, 4. As soon as I get 7, I want to stop everything and get out of the loop. I want to stop printing. So this is where the break condition comes in. Break actually just breaks the loop it is in. So let's say if I am in 2 loops, so and if I call break here, I'll end up reaching here. And if I call break again, I'll exit the outer loop as well. Break actually breaks the loop you are currently in and moves you out of the loop. So breaking here will bring me out. So what will this print? So when we get I is equal to 2, we'll skip printing that. And when we get I is equal to 7, we'll break it. So essentially what we'll get is 1, we'll skip 2, 3, 4, 5, 6. And once we print 7, but will we print 7? We won't. As soon as we get 7, we'll break out of the loop. So we'll get 1, 3, 4, 5, 6. Also, this if is a completely different if from this, since both of these aren't chained together. So once the compiler checks this if, it moves on to this second if. These are 2 completely different lines. It's not else if. If it was else if, the compiler would only check one of these ifs. It will check the first if. If it doesn't match, it moves on to the second if. But since that's not the case, these are 2 completely different ifs. So let me do it. Let's print it. For 10, I'm getting 1, 3, 4, 5, and 6. Exactly how we talked about. So let's start with functions. But before that, let me write some code to take n numbers as input and print their sum. So we'll take n and we'll run a loop. We'll make a number. We'll take that as an input and we'll print out the sum. Cool. So it is giving me the sum. Let's say I need to do it again. So I have to copy this code, paste it again, and I'll have to remove the redeclarations of some numbers. And let's see if 15 and let's say 3 numbers, 3, 2, 1. So it is working again, but as you can see, if I have to use the same functionality, I have to copy paste code, which is not really a good thing because this increases the complexity of the program. It is difficult to understand. I'll have to go through this piece of code, then I'll have to go through this piece of code again and try to understand both of them. And if there is some issue that let's say I've initialized sum with 1, that will be copied over throughout the program. So what we can do is we can take this piece of code, put it somewhere else, and ask the compiler to reuse this piece of code. And that is exactly what a function does. So what a function does is that it takes this code and moves it outside of main function and gives it a name. So we'll have a name and it will have some input values that we can give it. That is A, B, C, and it will give us an output. This is what we call as a function. So in order to define a function, you'll need three things. The first is what will the function return? That is the output from the function. The second is the name of the function. And the third is all the inputs that it requires. And then you have your block of code. This is how you define a function. This is where your code goes. So let's write a function that takes a number n and calculates sum from 1 to n. So let's think about what will be our input, what will be our output. So according to me, I need an input n because we will be computing 1 plus 2 plus 3 up to n. And what should be our output? We need to define a data type. So this will be an integer. So first of all, we'll mention the return type, that is int. Then the name of the function, sum of numbers, and then the input will be, which will be an integer n. This is how we define a function, and you'll see that this is very similar to something like main. And something that you'll realize is that this definition is very similar to the definition of main. And you are correct, main is a function as well. We are supposed to return an int from main, but we don't return anything. That is because main is a special function which does not return anything. We'll come back to this. First, we'll set up sum as 0, then we'll go from I is equal to 1 until I is less than equal to n. And at the end of a function, we return some value. We can only return one value. So make sure you know what kind of value you are going to return. And because the return type will be based on that. So we'll return sum from here. And how do we call it? To call this, we can just call the function and give it circular brackets and pass the value as 10. So this will essentially give us the sum of first 10 numbers. And we can store this in some variable and we can print that variable. So it gives us 55, which is correct. And we can call it any number of times. This makes it easier to write code, test code, and do everything because there's only one definition of this code. And we can understand it once and we can apply it everywhere. So I get 55 and 5050. Also, variables can have numbers in them. They just can't start with numbers. And they can have underscore as well, capital letters as well. So just keep that in mind. Now, I want you to write a function that returns factorial of a number. Shouldn't be that difficult, so go ahead and try it. Let's see another kind of function. Now, I want a function that takes two numbers, sums them and prints it. So let's see how it will look like. Let's start with the function name. Let's skip the return type. So sum of two numbers, and it will get two numbers. Let's say int a and int b. And what I need to do is int c is equal to a plus b, and we'll see out c. And when I come to the end of this, I realize that I don't need to return anything out of this because I'm done with the function. So what should be the return type of this function? Well, for these kinds of functions, we use a return type known as void, which means that we don't have to return anything. So this is our function. Let's try running it. Since we are not returning anything, we can't store the value in a variable, but we can just directly call it sum of. So it gives me 25, which is sum of two numbers. Cool. So we can have a lot of different return types. We can have int, we can have char, we can have float, basically all the data types. And there's another one, which is void, which means nothing. If your function does not return anything, we use void. And if we try to actually store this value, sum of AB, and we try to print this value, let's see what it gives me. It says that a value of type void cannot be used to initialize. So I cannot initialize a variable because sum of two numbers is a void function. Let's try to print the first n numbers of a Fibonacci sequence. What is a Fibonacci sequence, you might ask? Well, a Fibonacci sequence is where the first two numbers are 0 and 1, and every next number is the sum of the last two numbers. So we'll get 0 plus 1, 1, then we'll get 1 plus 1, 2, then 1 plus 2, 3, 2 plus 3, 5, 8, 13, and it goes on. So we can actually write a code which will be void Fibonacci, and it will get an integer n, and we can write the first number as 0, second number as 1, and since we are computing from the second number and we are going to nth number, let's print the first number and the second number. So we don't need to handle these two because they are already fixed. And for every number, what we'll do is in next number will be first plus second. So we have computed this number. Now we need to print this and then update the value of first and second to 1 and 1. Then we'll get 2 and we'll have to update the value of first and second to 1 and 2. So basically, whatever number we generate, we put that into second and we move the second number to the first one. And basically we are deleting this 0 completely. So let's just code it out. So we'll print the next number, we'll give a space, then we will say that, hey, the second number should be copied into the first number. Next number should be copied into the second number. And once we are here, we can just type return. This will do the same thing. Or we can skip this and it will return. So one thing about return is that whenever compiler sees a return statement, it stops the execution of that function completely and moves back to the main. All right, let's try to compile this. A silly mistake. So I never called the Fibonacci function. So it compiled and it ran completely fine. We went into main and we didn't have anything to do. So we just exited the program. So let's take an input. And since we don't have to do anything, we'll just say, hey, here's the number n and print all the Fibonacci. See, so let's compile it again and take in n. So we get 0, 1. I should have entered space here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm printing 11 numbers. First and second number, this should start from 3. So let's clear this, compile it again. So I'm printing 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. And this is correct. This is the Fibonacci sequence. So one thing you should know is that we can set up a function with any number of input arguments. We can have int n, int m, int a, b, c, whatever we need. But whenever we are calling that function, we'll have to pass all of these arguments. There are something known as optional arguments. So let's say we have a function that prints numbers from start to end. So we can pass 2 and 5 and it will print 2, 3, 4, 5. Okay. So I've given it an ending and starting number, and we'll go from start until end and we'll print I. So I want to print a range from 10 starting from 6. So it gives me 6, 7, 8, 9, 10. Cool, it works. So I'm giving it 2 arguments. If I call it with just 1 argument, it will throw me an error that, hey, no matching function to call range. It requires 2 arguments, but 1 was provided, which makes sense, right? What should be the value of start if I haven't provided it? So what C++ allows us to do is, let's say I want to make this function a little more dynamic, that I'm able to skip the starting number. And whenever I skip it, I want the start to be 1, let's say. So what I can do is I can just say that, hey, set this to 1 if it is not provided. So what this means is that if both the ending and the starting index are provided, we'll use them. If the starting index is not provided, we'll set it as 1. So if I call range 10 to 6, it will work. But if I call range, let's print a new line once you're done. So if I call range and I just say 10, it should print everything from 1 to 10. So it printed 6 to 10. These are known as parameters. And the actual numbers that we pass are known as the arguments of a function. And this is a default parameter, basically an optional one, which means we can skip the value here. One more thing I want to point out is, what will this code do? So it will start printing from 6, 7, it will print 8, and it will come to this line. And it will see, hey, I is equal to 8, which it is, and it will return from here. So the function won't execute past this at all. So if I call range 10, and if I try to compile it, so as you can see, we are printing 6, 7, 8, and the next line is printing 1, 2, 3, 4, 5, 6, 7, 8. So whenever we get a return keyword, we just return from that place. It literally means that, hey, stop the function, go back to main. So how does this work internally? Let's look into that. So what really happens is that whenever we are executing a function, we put that into a call stack. So when we start, our stack looks something like this. This is the call stack. And we'll have our main function here. And it will have all of its variables and everything in this stack. So whenever this main calls a function, that function is added to the call stack. And we pause whatever we were doing in main and start executing this function. So we won't do anything until this function execution is completed and this is removed from the stack. Similarly, once we are done processing the main function, we remove that from the stack as well, and we are done with executing the complete code. So this is a really simple function where you have two numbers and you print the sum. So what will happen if instead of printing the sum, I do x++ and y++, and I call this function and I print the value of a and b, let's say 10 and 15. So I get 10 and 15 back. I should add a space here. So I get 10 and 15 back here. What's really happening here? Shouldn't I get 11 and 16 because I'm incrementing the value? Well, not really. So what's happening is our main function has all of its variables where a is 10, b is 15. Whenever we call another function, that is the sum function, what we do here is we take x and y and we copy these value over to here. So x is equal to 10 and y is equal to 15 because that's how we have passed it, right? A's value goes into x and b's value goes into y. And we can do whatever we want with these x and y values, right? But changing these values does not mean that we are changing a and b. And there is actually no way to directly change the values of a and b. There are ways and we'll look into them. Similarly, we can't actually access x and y here. Why? Because these x and y variables don't really exist in the scope of main function. These exist in the scope of sum function. And once sum is done executing, these x and y variables are removed. So we cannot access a and b in the function, and we cannot access any of the function variables in main. And since we are actually copying this value over to x and the value of b over to y, we call this as pass by value. There is another way to call a function that we will look into at a later time. But what you can do is that you can do a is equal to sum two numbers and you can pass a and b and return an int, turn x plus y. This will update the value of a. But here we are specifically adding the numbers and returning them. So the value of this will come here and we are then copying it with the equal to operator. So we are actually setting the value of a ourselves. One more thing, that if you define a return type as int, end the function without returning a value. So if I try to run this, it will give me a warning that hey, a non-void function does not return a value. So if I don't return anything from here and just do x plus y, which does not make any sense, and I try to print a, let's see what I get. I get some garbage value, which I don't know where it has come from. So always make sure that you return something from your functions if it is not a void function. Also, coming back to the call stack, make sure you understand how a call stack works. Things are put into the call stack, they are processed one by one and they are removed. So let's say you had three things in the call stack. So when a new thing is added, it is added on the top and then this is processed first and then removed. And once this is removed, the next thing is removed and then the next thing is removed and the last thing is removed. So this is actually known as a last in, first out approach. That the last thing that came in is the first one that goes out. Let's move on to a really interesting topic, something that you'll use a lot, arrays. So let's say you need to define a variable. You can do that with int x equals to 10. Very simple. What if I ask you to define 10 more variables? Let's say you could do that. You write int x1, int x2, and you keep on doing that. And you initialize it with something, or you take the input from the user. That is another mess. So you do c in x1, c in x2. What if I ask you to do this with 100 or 1,000 or let's say 10,000 variables? Will you be able to do that? I don't think so. So that's where arrays come in. What arrays does is that we make a list of variables. So how do we write arrays? This is how we define a normal variable. And this is how we define an array. So we have an array with the name A. So there are 10 spots and each spot is an integer. So how do I access it? I can actually take inputs from 0 up until 8, 9. So that will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That will be 10 numbers from 0 to 9. So I can take input at A0, A1, A2, and like that. Or I can run a loop and I can go from 0 till 10, but make sure that we don't go equal to 10. The memory that we have is only from 0 to 9. The first element is at A0, and the last element is at A9. This means 10 elements. A10 is not accessible. So what we can do is we can iterate over all the indices. We call this as an index. So 1 is an index, 2 is an index. That this is known as index of an array. And we can take input at every index. And to print it, we can do the same. We can go from 1 to 10. This should not be equal to, and we can print it. Let's do with 3 numbers, and we'll need to update this to 3 as well. And let's print it. So I can enter 1, 2, 3, and I'll get 1, 2, 3 as the output. And these numbers have been stored in the array. But if I do try to access something like A10, which is out of bounds here, so I'm getting a warning that 10 is past the end of the array, which contains 3 elements, but I can still run it. So if I enter 1, 2, 3, it runs, but it starts to output some random character, which is 0. This is not something that you should be doing. You'll run into a lot of errors. Always make sure you only access the memory that you have with you. Similarly, if this was an integer array, we can define something like a double array if you want to store doubles. So double array, and we can have 10 elements. We can have a character array, and we can have 10 elements there. We will dive deeper into character arrays. They are very different than all the other arrays, but this is how you define an array. So now you might be thinking, so let's try to take the number of elements from the user, right? So we can take int n from the user, and instead of defining the array like this, we define it like this. This is a really bad thing. You should not be defining variable length arrays. We have something else in C++ STL that allows us to define dynamic arrays, and once we reach there, we'll stop using these arrays and we'll switch to them. So until then, you should know that this is not how we define arrays. It should work, but it's a really bad practice. Instead, what we can do is make an array of constant length and use that array. It will use a lot of memory, but this is a much better approach. So let's try this. So let's enter 4 numbers, 1, 2, 3, and 10. And we get those numbers back. So let's write a program that takes an array from the user, goes through that, and prints the minimum number out of them. So let's take an input. Let's define an array of 1000 length, and we'll take the array inputs from user. So what we can do is we can have an array, and we can assume that this is the smallest number, and then we can go over the rest of this array, and whenever we find a number that is smaller than this number, we can update the smallest number. So what we can do is we can assume that smallest number right now is 9. So I go over to the next number, which is 2, and I see that is it smaller than the smallest number, and I find that it is true. So I can update the smallest number to be 2. Then I go to 1 and see that this is smaller than the smallest number. So I update the smallest number to 1, and then I go and check 7. It's not smaller than 1, and then I go and check 5, and then I check 0, which is smaller than the smallest number. So I update this with 0. Similarly, I check with 3, and 3 is not the smallest. So our answer will be 0. Let's try to implement this. So I say that whatever is at the first location, which is the 0th index, is the minimum number. Then we'll go from 1 and we'll go to n, not up to n. Let's say if n was 10, we'll go to 9, and we'll check if the current element is less than the minimum. Let's name it smallest. We'll say that the smallest number is the current one. And once we are outside of this, we can print the smallest number. So let's run it. Let's enter 5 numbers, and let's enter 7, 9, 3, 1, 0. And we get the output as 0, correct? But let's say if I run it and I don't give any numbers, I get some random value. So we didn't make an array, but we try to read the first element of that array, which is wrong. So instead of using this or using the number 0, which can be wrong as well if we have like -1, -2, -3. So instead of using this, we can use what we know as int max. So we can set it to the maximum number allowed in an integer. Cool. Let's see how arrays are stored in the memory. So I can use cin a0 and then cout a0. This is like accessing an integer. What will happen if I print a? And let's comment these both lines. What output should I get when I print a? So this is not a variable. So should I get the value at a0, or should I get the value at a1, or what should I get here? Let's see. Let's compile this. So we have to give an input. Let's say 10. So what I get is a memory location. This right here. How do I know that? The 0x. This means a hexadecimal number, and this usually means that this is a memory location. So why has it given us a memory location, and what does this memory location mean? Let's see the memory location of the first element. So in order to see memory location of an element, you can use the destructure operator. We'll go over this in a lot more detail when we talk about pointers. So adding ampersand before a variable gives us the memory location of that variable. So remove these lines. So let's build it again and print it. So these both are the same memory location. This is our array and this is in a really big memory. So this is the memory that we have been assigned, and this part is what belongs to A. And how many bytes do we have? So the array is of 1,000 numbers and each number is of 4 bytes. So we have like 4,000 bytes. And the memory location of the first byte is exactly this. And I can actually see the memory location of the first 10 bytes. So let's go over 10 numbers and we'll print out the memory location of AI, and we'll print everything in a new line. Let's actually see what's going on here. So the first memory location, so the 28, this is for A. Then I print the memory location of the 0th index. So as you can see, so we get 28, then we get 2C, that is 4 locations away. This is hexadecimal, so it goes from 09 to 0A, 0B, 0C, 0D, 0, 0E, 0F, 10. This is how it goes. So we go from 28 to 2C. So we go from 8 to 1, 2, 3, 4. So 4 bytes. And then we go to C. And then from C we go to, we use 1, 2, 3, 4 bytes until F, and we go to the next 30. And then this is easier to see, 30, 34, 38, then 3C, 40, 44, 48, and we keep on going on. So as you can see, this is the memory location of the array. So A actually consists of this memory location, that is 328, 0x and 328. And this memory location in turn is the memory location of the array. So what will happen if I make a function increment array and we get an array in this? And this is how we pass an array in a function. And I go over every element and I do AI plus plus. Cool. So what we are doing is we are taking 5 numbers from the user and we are calling an increment function which is going over all of those 5 numbers and incrementing it by 1. We are then coming out of it and printing the array. So from what we know about it, the main function has its own variables A, B, C, and whatever function we call, so this will be increment function, it will have its own variables A, B, C. And so whatever change we make into these ABC values, they won't affect our main values, right? So that should be the case with arrays as well, right? Let's try to build it. So I'll enter 1, 2, 3, 4, 5. And what I get is actually 2, 3, 4, 5, 6. So we have actually changed the value of the array, but how is that possible? You know what? Let me comment this out. And we won't print or anything, but all I want to do is see the value of A here, that is the memory location, and the value of A here. And I'm not returning anything. So first we'll print the value of A outside of the function in the main function, and then we'll print it in the increment function. 2, 3, 4, 5. So what's going on here is you have your main function where A has the value 0x328, and then you have your increment function where A has the same value that is copied over 0x328. The value that is copied is the memory location, but in the memory where our array is actually stored, where we have the values 1, 2, 3, 4, 5, this is at the memory location 0x328. And whenever we use this memory location, we are actually going to the same memory here. So it doesn't matter if we increment the array from the main function or the increment function, it goes to the same memory location and increments the array. So the array is not really copied, only the memory location of that array is copied into the function. So there's only one copy of the array and both these memory locations are accessing the same copy. So now you know that when we pass an array, we get the memory location of that array and we can actually access the original array, and that array will reflect all throughout the program. Cool. Let's try to implement linear search. So what I can do is I can take an array from the user and take a number k, and I can check if that number exists in the array or not. Let's say if our array is 1, 2, 3, 95 and minus 10, and I ask is 95 in my array, so I should get a yes. Let's do that. So I've taken the array from the user. I'll take k from the user. This is the element to be searched, and I'll go over all the elements, and I'll keep a boolean that is found, and I'll set it to false because we haven't found it yet. So I'll go over all the numbers, and if the number at ith index is equal to k, I can write found equals to true, and I can break from here. Once I'm outside of it, I can check if found equals to true, I can print yes, else I'll have to print no. Let's try to run it. So we'll enter 10 numbers. Okay, I haven't taken the input of n. K int n. Let's prompt the user as well. Enter the size of array, enter the elements. We'll have 5 elements. The elements will be 1, 2, 99 minus 3 and 120. And let's see if we have 99, and we do. So let's do it again, and I try to search 10. I don't get it. So this is known as linear search because we are linearly searching in the array. We are going element by element and checking if that element is equal to what we want to find. You know what? Let's move this into a function first. Bool, because we are returning true or false, linear search, and we'll get an array. We'll get the number of elements and we'll get k. And we can actually take this part, and instead of a bool, we can return true here. And if we haven't found it after going through all the elements, we can just say that we didn't find it. We can do bool found is equal to linear search in the array, n elements, and I'm searching k. So this does the same thing. 3 elements, 1, 2, 3 is 3. Yes, 3 is there. So instead of bool, I want you to return me an int, and that will be the index where this element was found. And if it is not found, return me -1. So go ahead, try to do it yourself. So there's one more way to search in an array, that is binary search, and it can be applied if the array that we have is sorted in increasing or decreasing order. But I won't pick that up right now. I'll let you go and check that out. Along with that, try to see how you can actually sort an array. You have insertion sort, selection sort, bubble sort, merge sort, quick sort. Some of them will be a little difficult, but go ahead and try to implement bubble sort, selection sort, and insertion sort yourself. And binary search as well. So there's actually a few different ways to initialize arrays as well. So let's say you make an array of length 5 and initialize it with 1, 2, 3. What this will do is it will make an array with 1, 2, 3 and rest of the elements will be 0. Or you can go a step further and initialize the array without a length and just all the elements. What this will do is that it will create an array of length 4 and it will set the elements like this. Cool. Let's move on to character arrays, because character arrays are a little different. So a character array is essentially a string that is a word or a group of words. So you can directly define it like this, like we defined the integer array, or you can define it as char sp size 10, and you can define it like this. How it works is that it stores 10 bytes of memory, but you are only allowed to use 9 bytes out of this. So you can use S0 up until S8, but you cannot use the byte S9, because what happens in a string is that because we use the last character to store the null character, and a null character is basically \0 or ASCII 0, and this is how it actually looks like. So this is actually used to identify when a string has finished. So this last null character marks the end of the string. If I hover over ABC, you'll see that it shows us the length as 4, but we have only initialized 3 different variables. Why is that? Well, it uses an additional spot to store the null character. And why is that? Well, that is because cin and cout works a little differently. So C++ knows that we'll use character arrays for strings, and it doesn't make sense to loop over all the elements. We can do that, but that's really cumbersome. So what C++ does is that it has allowed us to use cout directly with S. And what cout does is it sees that S is a character array, so it starts printing every character. So it prints A, B, C, and then it runs into null character and it stops printing. Similarly, it will print A, B, C, D, E, F and runs into null character, and it will stop printing SB as well. So if I run it, you'll see that it has printed ABC, ABC, D, E, F. And you know what? If I give a null character in the middle, it will stop printing after A and B. So let me show you. So it stops printing as soon as it gets the null character. But if I don't have a null character, F, G, H, I, J, K. So let's say I give it 10 characters and I give all the 10 characters. So it will actually drop J and it will put a null character there. So it actually tells me that the character array is too long for this variable. But because it has 10 spots and I'm using all the 10 spots, and it doesn't have a spot for a null character. So now I can add elements up until I. But what will happen if I go here and change the last character to J? Let's see what happens. So what happened here is I went ahead and I removed the null character and updated it to be A, B, C, D, E, F, G, H, I. It was something like this. And what I did was I removed this null character and I added J here. So what cout did is it started reading from here and it kept on reading and it went above our character array and it printed 4. And this 4 is some garbage value it got in the actual memory. So this is how it is printing. So it got 4 and then it got a null character and then it stopped printing. So it is very important that you take care of this null character and you add it when you want the string to end. So let's write a function that takes a string and prints the length. So we'll get a character array and we have to give its length. So we'll start with int length. So we'll set the length as 0. We'll go over all the elements up until s of I is not a null character, and we'll increment the length, and once we are done we'll return the length. So I can actually print the length of s. So it gives me 3, which is the length of s, and it could be anything and it should work. So that's 65. You can pause the video and count it if you want to. So if we actually define it as, we can only use 9 places because the last one is reserved for null character. Again, let's define a character array of length 1000 because we don't define arrays with variable lengths. I want you to Google why we don't do that and tell me down in the comments below. So let's see in S and let's print the length of S. So what we are doing is we are taking the character array input from the user and we don't have to actually go element by element. We can take the character array as one. So let's compile it. So it's waiting for an input. So I'll say subscribe to Ashhad, but it has given me 9. Why is it 9? Let's print S as well and let's run it again and I'll copy paste this and it has only taken subscribe and it hasn't taken anything after that, and 4, 5, 6, 7, 8, 9, and it has not even taken the white space. So what cin does is that whenever it sees a space or something like that, it stops taking the input. This is how cin is defined. So if we have to take an input for a line and we need to include the spaces, we use something known as cin.getLine. So, and we have to pass the array. We need the total number of elements we can take. And if we have a delimiter, so that is stop taking input when you find this character. This is usually a new line character and we can skip it because that is an optional parameter like we talked about. So let's remove this. So subscribe to Ashhad. So we get the entire string, subscribe to Ashhad. This is how we use the cin.getLine function. So there are a lot of questions that you can do on strings. So let's say I want to take the input and then reverse the string, and I pass the string here. And once I reverse the string, I need to print the string. So let's write a function to reverse a string. So first we need the length. We'll get it from the length function. So we'll give it, cool. So how I'm thinking about reversing it is, since this is how the string is stored. So this is HELLO. So what I'm thinking is, let us keep the index of the first and the last element, swap them, increment the pointer up until we reach to a position where both the pointers are pointing to the same word or they have crossed each other. So my first pointer, the left pointer, will be at 0 and the right pointer will be at length -1. And while left is strictly less than right, what I can do is I need to swap. So what happens while swapping is, you actually, if you have something here, and you need to swap both of them, you actually need a third storage, which will be temporary, and you'll have to move one of the elements here, move the second element to the first element, and then copy this back here. So something like this. So I can have a character temp char, and this will be equal to element at left, then right will be copied over to left, and we'll copy the temporary element back onto right. So this is what we are doing. And once we are done with this, we have to increment the left pointer. So it moves forward and the right pointer moves back. And since we don't need to return anything, we'll put it as void. This will be temp char. And let's see. So we'll get a string. We'll print its length. We'll reverse it and we'll print it. So we'll say subscribe to Ashhad. So we are getting subscribe to Ashhad in reverse order. Now what I want you to do is look at this. So we were able to reverse the entire string. If I reverse the part of string again, so this becomes Ashhad, this becomes to, and this becomes subscribe. So if you can see that we have essentially reversed the entire string word by word. So this string becomes Ashhad on reversing, this becomes to, and this becomes subscribe. So what I want you to do is you have a reverse string function, start running a loop, and whenever you find a space or whenever the string ends, keep a pointer and reverse everything before that. So reverse this, update your pointer to 2. Then reverse this, update your pointer to E, and then reverse the entire thing. So you'll get Ashhad to subscribe, reversing this string word by word. So this is a very popular question that you can see on LeetCode. Don't do it on LeetCode because that uses string. So this is a very popular question that you can do it yourself. Try to solve it. So string has a lot of functions that we can get from C string library. So there are a lot of different functions for strings. So we have strcpy that copies string B into string A. So let's say I want to copy hello world into the string S. So I can give the string here, or I can actually make another string. Let's make it A, let's make it B, and this can be hello world. So what I can do is I can copy B into A and I can print A. So it copies hello world, and if I copy just A, so it copies just A. So it copies string B into string A. Next we have strcmp that compares two strings if they are equal or not. If they are equal, it gives me, let's see what it gives me. So let me print if they are equal. Ideally it should give you true or false, but that's not how it works. It gives you a random number if they are not equal. So it's not random, it's basically the difference between characters. So if they are equal, it should give you 0. Yeah, it gives you 0. Actually, what you can do is you can print this. If strcmp equals to 0, this will give you true. This is essentially true. It's a Boolean. The length function that we have defined here, it's already defined in the C string library and you don't need to define it again. So it is strlen and you can pass the string here. So it gives you the length as 4. So this is the same as the length function that we have implemented. So let's do a question where we are given a string and we need to print the element with most occurrences. So for A, B, C, D, A, B, A, we need to print A. So how we can do that is we can keep a count of every character that we have encountered till now. In order to do that, let's create an array, and I'm making this a 130 length array because there are 128 characters and I just like to keep some buffer. And so let's set this to 0. So if I set an array like this, what it does is that it copies the elements that I give it and then sets the rest of the elements to 0. So I can just put this as like this. So it will copy this element and set the rest to 0. So now I'll go over. So I'll go over all the elements until I get a null character, and I'll go to the occurrence of that character and I'll increment it. Now I'll go over occurrences array. Let's keep a best character till now and let's keep that as A. So I'll go over all the elements in the occurrences. The ith character has occurred more times than the best character. What we can do is best character is equal to I. And once we are outside of this, we can actually print best character and we should be done. So let's copy this and we print 97. I've saved best char as int. Let's do it char and we get A. Let me just change this so that we actually get B. This should give us B. So this gives us B. So this is how we solve a normal question in strings. Try to solve a lot more of these questions because strings are really important and really difficult to actually solve. So unless you practice, you won't understand a lot of these things. This completes strings or character arrays. There are a lot of questions on this. I would suggest that you go ahead and check them out, or you can check the description. I'll try to compile a list of questions that will help you throughout this video down in the description. Lastly, let's talk about 2D arrays. So have you seen a chess grid? So this is how a chess grid looks like. I'm just drawing 4. So, but it is 8 by 8. That is 8 rows by 8 columns. This is one row. So this is row 1, this is row 2, and this is column. So this is how you define a grid. So in C++, let's say if I want to keep n arrays. So I'll need one array, A1, the second array will be A2, third array will be A3. And to make a chess grid that is 8 arrays, I'll need A1, A2, A3 up until AN. That will be A8. So instead of actually creating 8 different arrays, what we can do is we can make 2D array. And how do we make one? Well, this is how we define a normal array of length 8. And we add one more square bracket and give it another 8. This will create a 2D array of size 8 rows by 8 columns. So let's see how it goes in the memory. So to store a normal array, we actually reserve the length of the array in the memory, right? So A8 will actually reserve 8 bytes and give it to A. But in the case of 2D arrays, now we have A8 cross 8. So in the case of 2D arrays, we do it row wise. So the first row is stored here, then the second row is stored here, the third row is stored, and so on. It keeps on going. So if I print A, I will get the memory address of A00. Cool. So this is how it is stored in the memory. So how do we actually read data into this? So for this array, so this box can be accessed by accessing A00. So this one is A01, this one is A02, and so on. So from this, what we can define is that Aij is actually ith row and jth column. So we can actually go over it row wise. So we can first take the input for A00 and then A01 and then so on. Then we can go to A10. So in this, we'll first run a loop over I is equal to 0, I is less than rows, I plus plus. And then we'll go over the columns. That is J is equal to 0, J is less than columns, J++. And then we can take in the input as C in Aij, or we can go over column wise. So we can go over columns first. So this will go over this. So we'll go over columns, then we'll go over rows, and then we'll take the input in Aij. So it depends on us, like what helps us to get the solution. But you can go over it row wise or column wise. We usually go over it row wise. So in order to define a 2D array, we can define it as int a 10, 10. Again, don't put variables here. Try to keep them constants. 10. So this will create a 10 cross 10 grid, and we can actually initialize it here itself. So this is how we'll go. So here in the first row, let's put 1, 2, 3. In the second row, let's put 2, 3, 4, and we'll skip the rest. So let's see how our array looks. So we'll go over all the rows. We'll go over all the columns. And we'll print the value, take a space, and then print a new line. It has initialized the array, and it has set everything else to 0. So if you want a 2D array and you want to set everything to 0, you can just do this as well, and it should work. So this is how you do it, or you can just not define it here and take the input from the user. As we know, in the memory, the first row is stored first, then the second row, then the third row, and so on. So if you want to access Aij, what you are essentially doing is that let's say you are accessing A2, 3. That is the third row because it starts from 0. So this is the third row, fourth column. So in order to access this, what you are doing is you are skipping the 0th row, the first row, and you're moving to the second row. And here you're not accessing the first, not the second. You're accessing the fourth element, that is right here. So how many memory have you skipped? So all the memory in one row. So that will be the number of columns into how many rows you have skipped. So you have skipped 2 rows. So that will be in C into I plus you have skipped 1, 2, 3 columns. So that will be, so in order to get the memory location that you have currently reached, you need this memory location. That is the memory location of A plus number of columns in each row and multiplied by the number of rows. That will be 1 row that you have skipped, 2 rows that you have skipped. So that will be 2 here, and you have skipped C columns in every one, so C columns, and you have skipped J elements in the second row as well. So to reach here, you have essentially moved these many places. But so what this tells me that if you want to go to a location I or J, you need to know the number of columns. So how many columns are there? So if we see here, the number of columns is equal to 10. So this is actually very important. So I need to know that there are 10 columns. So this number is way more important than you actually realize. And that is because the compiler needs to compute this, and the number C is actually coming from here. So because of this, whenever we actually pass a 2D array, so let's say I make a function print that prints the 2D array, I can skip the first one, the number of rows, but I have to tell the compiler the number of columns in every row. that's it. So I can go over this and then I can give the number of rows and columns that I'm actually using, because I can create an array of size 1000 by 1000. Maybe I just want to use 10, 10. But in order to compute the memory location, the compiler must know this to be equal to 10,000. So I can go over n I plus plus for n j is equal to 0, j is less than m plus plus cout a I j. Once we are done printing a row, I enter a new line and this is it. So let's make this 100 and let's just see if I'm able to print it. Let's call print array and 10 cross. Actually see this error message that I'm getting. So it says that argument of type int, it doesn't care about the number of rows, but it cares about the number of columns. It says that you've told me 100 columns here, but the function accepts 10,000 columns. So I need to update this to 100 columns as well. And now I should be able to print it. It won't print anything. It should print garbage values or zeros depending on, okay, it prints all the zeros. Cool. These were 2D arrays. Now what you can do is try to print this 2D array in a lot of different ways. There's a lot of different questions on this. Secondly, what you can do is take the input from the user, print the minimum element in every row, and then print the minimum element in every column, and tell me down in the comment section what should I cover next. Cool, you can find a list of questions that you can solve along with me down in the description, and don't forget to subscribe and tell me down in the comments if you like videos like these and what should I cover next. Thank you, bye bye.